In this segment, I'm going to show how to make a modified 2.4 gigahertz video receiver. I've already showcased the not-so-original, although interesting idea of creating a portable video scanner. This is mine. This is a 2.4 gigahertz video receiver that has auto scan features, a whole bunch of other crap. I like it. Modified with a panel mount end connector coupled into a 15 decibel gain helical antenna using a Game Boy Advance as a primary screen, a 9.6 nickel metal hydroxide 1.6 amp or 9.6 volts at 1.6 or 1.8 amp. Either way, this is my setup. Yours may differ, but what do you need to know to actually modify a video receiver? Well, first off, you have to understand that it runs off the 2.4 gigahertz frequency, and that is what we call a microwave frequency. Frequencies have names: UHF, VHF, super high frequency, blah 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 blah. This is microwave. So that means you need to have coaxial cable, the type of cable to carry that frequency to your device that's rated for microwave. Now, this is RG6 coax. This is commonly used in satellite and cable TV installations. You see this? This is 75 ohm coax. This is completely wrong. Do not use RG6 or RG8 or RG58. You have to use microwave class cable. No, niet, nein, no, stop, forget, no RG8. Okay? No RG6. Don't use it. For the love of God. No. Whoa, did I mention? No! You can't use it. What can you use? This is LMR 400. Now, I have to personally thank both Dave and Andre Croy. Dave helped me out by obtaining the appropriate radio connectors, and Andre Croy helped me out getting the cable. LMR 400. LMR stands for Land Mobile Radio. This is microwave cable. This is designed for in excess of 6 gigahertz. We're operating at 2.4, so this is good. The problem is, it's stiff, it's bulky. How in the hell are you going to attach this bulky cable to something that has such a small little piece of coax coming out of it? Well, that is where lower diameter LMR 195. LMR 195 is thinner. Now you might be saying, okay, what's the big deal? Why should I care about what coax do I use? Okay, coax is like a pipeline for water, okay? It's going to carry your signal, and if your pipeline has holes in it, if your hose has holes in it anywhere, that water is going to leak out. So if you use RG6, RG8, RG58, RG58U, any of the other lower frequency cables, your signal is going to leak out of the side of it, and you're going to get signal loss. Significant amount of signal loss, and your signal is measured in decibels or dBs. Now, having a thicker coax means you'll have less loss. The problem is it's bulky and it's unwieldy. It's very difficult to go and run short lengths of this because it's so unwieldy. But the thicker stuff is good for really, really long runs. The thinner stuff is good for shorter runs. All of my handheld devices that I'll be showing you how to mod and create in this series will be either using LMR 400, LMR 195, LMR 100, or LMR 200 coax cable. Primarily LMR 195 and LMR 400. They are the two easiest forms of microwave coax that you can get your hands on. I'll try to put some show notes up on where to get it. We'll get into that later. I think I've explained enough about coax. So, you got your hands on some coax, how the hell are you going to go and connect it to your device? And let's go to the table side and I'll explain RF connectors themselves. Again, I'd like to personally thank Dave and Andre for getting me a lot of these connectors and the coax cable that I'll be showcasing. But with enough ass-kissing, let's get on to the connectors and such. Okay, let's start out with some commonly used stuff, okay? Here's my Linksys router. My Linksys router has something called an RP TNC, or reverse polarity TNC, okay? I've got an RP TNC adapter around here somewhere. I got so much crap. Here we go. Here's the mating end. Now, I really don't feel that I should have to explain male and female to you. Really, you should have an understanding of the difference between what male and female is, you know, what boys have and, you know, girls don't, and vice versa. So, this is a reverse polarity TNC. This is a reverse polarity TNC. But I don't feel like making custom reverse polarity TNC antenna cables just for this, so I bought an adapter. And this is going to turn it into an end connector. Here is another end connector. This is called a panel mount 4-hole end connector. They also come in a 2-hole variant, which I didn't purchase because I don't care. This is another form of panel mount, but this one is designed to crimp onto LMR 195 cable. And here's its bigger brother. This one crimps onto the actual coax of LMR 400. We also have something called panel mount. Now there's a little nubbin and a little nut where we're going to be using this little guy later to build some antennas. Now we've also got reverse polarity SMA, as well as the mating connector for the coax. Now this has a crimp collar for LMR 195. This has a crimp collar for LMR 195. So what we'll be able to do is, by taking this connector, we're going to crimp it onto some cable and then solder that cable leading into the RF box of a video receiver. Before I move on too far, Wi-Fi card. See those tiny little nubbins? See, those are called high-rose connectors, abbreviated UFL, also known as iPACs. Now, these are the ones that are found. This is literally an Intel Pro Wireless 2200 Wi-Fi card. These connectors are not rated for more than 50 insertions. They're low usage. Once you plug them in, don't remove them. So it'd be a good idea if you want to have a Wi-Fi card. Like, here's my tablet, which you guys see often. I've built in a reverse polarity SMA on each side, and here's a simple, crappy rubber duck antenna, so I have an antenna. And here's the adapter that goes from reverse polarity SMA to N, so I can use big beefy LMR 400 on little itty bitty, crappy reverse polarity SMAs. Okay, I've tried to explain as much as I can off the top of my head. I'll put a lot in the show notes, I'll put a lot of pictures up. But let's get on to the mod process, shall we? Here we have typical soldering stuff. We've got 35-watt iron, solder, desoldering braid, basic tools, cutters, needle nose pliers, angled needle nose pliers. Got a couple pair of tweezers, got a couple of screwdrivers, got some kind of, box cutter, razor blade, whatever. Go slit your wrist, go ahead and die, I don't care. We got our 2.4 gigahertz security camera receivers, and we have some LMR 195 coax. That's going to be the prime coax of choice for a lot of the segments. And here is a female panel mount end connector. And here's a crimp-on female reverse polarity SMA for LMR 195. When you get your coax, make sure that you get the proper connector for crimping on. I'm not going to get into the process of using the crimpers. There's plenty of information on the internet. I also did a segment on Amateur Logic, I do believe episode 12, on making your own homemade crimpers so you don't have to go out and break the bank. But anyway, what I'm going to do is I'm going to crimp on. Well, first I'm going to solder a length of this inside the RF box of this receiver. Have a short length of cable leading into this female connector. This female connector will then be put inside of, the entire thing will be put in some kind of case once the design is finished. And that is that. Now you have to remember that radio acts like water in a very weak sense, that if there are any holes or any gaps anywhere whatsoever, if you have a break in the shield of your coax, signal will leak out of there. Now, with all of that said, let me explain the RF box. Now, this is a 2.4 gigahertz video receiver made by X10. It had a panel antenna over here, but it broke. I think this coax is LMR 100. I can't be sure. Because I'm not sure, I can't order the proper crimp-on connector. Once you crimp a connector, there's no uncrimping it. That's the end of the story. Now, yes, you can use this coax right here and solder your center conductor right in like so, but how are you going to get that shield to make sure that it shields the outer signal? You'd have to kind of bend and flex and solder the coax. Here, let me see if I can get a better connector. You'd have to solder it like that, which is explicitly what I've done in my other scanner. But this isn't the appropriate way of doing things. It's not a good idea. The best way of doing this is either running the coax directly into your antenna, like they did here. This just solders directly into the antenna, or replace the coax with a known, better form of coax with the appropriate radio connector. So this is one of my earlier model scanners that I did all my experimenting on. That's why all the crap is hanging off of it and it looks like crap. But anyway, they have these solder points that have these little wires that hold the shield on. So using your soldering iron, desolder that off. And here's the inside of the box. Inside of this box, if you notice, let me see if I can get a good shot, you can actually see the center conductor and the shield. Now this entire box is a radio shield. Metal reflects and contains radio waves. So when I put this top panel on, this isolates everything inside. It's shielding because this circuitry is very susceptible to interference. So what I'm going to do is I'm going to carefully desolder the center conductor, desolder the surrounding shield, and take this off. Using a razor blade, I peel back some of the outer conduit, and I shave back some of the shielding, and I've taken the signal wire, and I've pre-tinned it, and I bent it at a small angle so it'll match up with my circuit board, and I've pre-tinned the outer shielding. Now, the hole in the side of this box was too small, so while I was off camera preparing this, I had to use my drill to make the hole a little bit wider. So, see how that fits directly on that nice snug little signal wire? And because it's pre-tinned, all I've got to do is take my iron, tack it on, there you go, there's the signal. Then you go and take some solder, everyday solder, and because it's the coax is pre-tinned, that'll stick nicely. And there's your shield. That's it. Now you've just modded that with an however long length of LMR 195 cable, which you can either directly solder into an antenna or terminate with a connector, which is what I'm going to do. Now it's just a matter of putting the RF box back on. Me, personally, I found that leaving the RF box top plate not soldered down has absolutely no effect on the performance of the scanner. So you can just push that down, and yeah, I'm lazy. I don't want to put it on all the way. Just whatever. There we go. It's on. Shut up. Go away. I'll give you a quick rundown on how to crimp stuff. The first thing you have to do is put on this little tubey thing. This is called the crimp collar. Second thing you have to do is you have to peel back this outer insulation to the length of your connector. Then you have to fold back all of your shield. This right here is called your dielectric. It's covered in some aluminum foil. So when you cut this, so you can put on the center conductor pin, like so. Make sure that they're not grounded. Make sure they're not touching. So visual inspection of that. What I like to do is I like to cut this back and then try to make sure that the center pin fits. Then I pre-tin this with a little bit of solder, and then just like so, there you go, and you get that soldered on. Now make sure you don't have any solder spikes around that. You might have to go and take a file or some desoldering braid to clean that up. There we go. Good as I care to get it. Okay? So we got the crimping collar on, we pulled the shielding back, we exposed some of the dielectric, and we trimmed back some of it so we can crimp or solder on our center conductor. Then we take our jack and we cram it on, make sure it's in there nice and good. We fold our shielding back up and over, like so. We take our crimping collar, put it around like so. Now would be a good time to take a razor blade and trim all of this off, but for time's sake, we're just going to go and take, oh, there we go, our crimpers. We're going to put this in the proper slot, and we are going to give it a squeeze. There we go, crimped on. Now it's just a matter of taking your mounting hardware that came with it and mounting this to whatever box you want. There you go. Now this process of modding gear will apply for practically anything, and later on we'll get into different devices like USB sticks and PCMCIA cards and whatnot, but that's it.